This might just be the ultimate in DIY security for any internal door in your home or workplace. You may already be familiar with two-factor authentication for accessing secure systems such as your online banking, your Facebook, or your email account. Well, this system uses three-factor authentication, and I'll show you how it works now. As you can see, the door is firmly closed and locked, and we can't access it without the three factors for authentication. The first of which is a standard keyfob, which you might already have one similar to this for your workplace. Present that here. It recognizes that as me, and I'll enter in my unique PIN. 1, 2, 3, 4, 5, 6. It then generates a unique one-time passcode and sends it to my phone. Here it is. Into that 2, 4, 7, 3, 6, 3. And as you can hear, the door's unlocked. We can open it and access is granted. Keep watching and I'll show you how to build it. To build this project for yourself, you will need a Raspberry Pi. I'm using a Raspberry Pi 3 with built-in Wi-Fi and a case which helps with protection and mounting in the wall. A power supply for your Raspberry Pi. An RFID reader. This one simply plugs in via USB and acts like a keyboard, inputting the code from the RFID fobs and cards. A touchscreen LCD for the Raspberry Pi. A GPIO expansion board. A ribbon cable to attach the expansion board, a female to male ribbon cable for attaching the touchscreen, a 5-volt single channel relay switch, an electronic door strike, a computer power supply and power lead, and some DuPont cables for attaching the relay switch. There are purchasing links in the video description for everything you'll need, so why not pause this video now and take a look. You'll also need a few tools, so make sure you've got all of the following before you get started. A multimeter for checking voltages, various sizes of screwdrivers, a precision set like this would be ideal, some wire strippers, some wire cutters, or you can just use a pair of scissors, a soldering iron, some chock blocks for connecting wires together, and a glue gun. The very first thing we need to do is get our LCD touchscreen working. Depending on the model you purchase for your build, it may just come with drivers to install, or it may come with its own operating system image for you to write to your Raspberry Pi's SD card. That's the case with my one, so I need to use Win32 Disk Imager to write the image to my SD card. Make sure you select the correct drive to write to so you don't accidentally erase any external hard drives or anything like that. Once that's complete, pop the microSD card back into the Raspberry Pi and fit the LCD to the GPIO ports like this, starting at the top end, which is by the SD card slot and away from the USB and Ethernet ports. Next, take the micro USB power lead and plug it in to boot up the Raspberry Pi to confirm that the screen and the touchscreen element of it too are working correctly. As you'd expect, the orientation of the display is in landscape as standard, but for our virtual keypad, we want the display to be portrait, so we need to change some config files to achieve this. With your Raspberry Pi connected to your network either via Wi-Fi or an Ethernet cable, shell into it and open up the config.txt file inside the boot directory. This file determines the orientation of the display. We're looking for a line towards the bottom of the file which contains dt overlay equals waveshare 35A. And to that line we're going to add a semicolon followed by rotate equals 180. Save and exit. Next we need to rotate the touchscreen to match the display, so we need to open up the 99 calibration config file. Don't worry if you don't catch the full path, details are in the video description. Inside this config file we first need to change the swap axis option from 1 to 0 and then enter in the following base values for the calibration options. Once you've done that, save and exit. Then you can reboot your Pi, and once it boots back up, your display should be rotated to portrait. Whilst we're in the shell, now's as good a time as any to install the database which will hold the access control list for our door entry system. We'll install a full LAMP stack so that we can use phpMyAdmin to access the database, and this also means you can create your own web interface using PHP to add and delete users to the system easily in the future. First off, we'll install the Apache web server with this command: Once that's set up, we'll install PHP and then MySQL. As part of the MySQL Server installation process, it'll ask you for a nice secure password for the root user, so enter one in and make sure you don't forget it. Finally, once MySQL is installed, we'll restart Apache and then install phpMyAdmin. As part of that installation process, it'll ask us which web server we want to configure to use it, so make sure Apache is selected and then select OK. We'll allow phpMyAdmin to install and configure its own database automatically, and then enter the root password that we chose earlier when installing MySQL to allow phpMyAdmin to create its own database and user. Next, we'll create a secure password for that user. Once all that's installed, you can type your Pi's IP address into your web browser, followed by /phpMyAdmin, and then log in with the root account you created when installing MySQL. Now it's time to install the Python script, which is like the glue that binds everything together. It receives the user input from both the keyfob and the touchscreen, it talks to the database to see who's allowed access, and it uses Twilio to send an SMS to the user. Click the link in the video description to download the Python script to your Raspberry Pi and the blank MySQL database structure to import. Once you've imported the database file via phpMyAdmin, you'll see the database contains 3 tables. The first is called Access List, and this table contains the details of everyone with access to the area secured by our locked door. Here you can see I've added a couple of users with their name, the RFID code number of their fob, their PIN, and their mobile number for the SMS two-factor authentication code to be sent to. We also include an image file so that the welcome screen can show a headshot. Make sure this is a GIF file and store it in the same directory as the Python script. Second, we have an access log table, which records all attempts, successful and unsuccessful, to access the system. This records any RFID codes presented to the scanner, whether they were granted at the time, what PIN was entered, which mobile number a one-time code was sent to, and whether it was entered correctly, etc. This logging information will be very useful in the real world, both for diagnosing problems with legitimate users accessing, as well as gathering evidence of anyone trying to gain unauthorized access. The final table contains our Twilio account details, which we use to send the text message which enables the final part of the authentication process before the door is momentarily unlocked, allowing access to an authorized party. With the Python script downloaded to the Raspberry Pi user's home directory, make sure you install all the dependencies required by the script. Once you've done that, we need to make the script auto-load whenever the Raspberry Pi starts up. To do this, we need to add a line to the auto-start config file. Type this into your terminal, and then add a line like this, @sudo python lock.py, then save and exit. With everything set up on our Pi, it's now time to disconnect the screen and put the Pi into its protective case. To maintain access to the GPIO ports, we use a short female to male ribbon cable, and we also need to add in a GPIO expansion board too. This is because the touchscreen LCD uses up some pins that we also need to use in a moment for our relay switch, namely the 5V pins. If you prefer, you could also power the relay from another 5V plug from the power supply unit instead. To connect the screen to the board, we need another long ribbon cable, and you'll need to carefully bend a couple of unused pins out of the way in order to make this fit. Then connect the touchscreen and power up the Pi again just to make sure everything is still working. The next step is to connect our relay to the GPIO ports. It's a 5V relay, so the positive pin needs connecting with a DuPont cable to a 5V pin on our GPIO expansion board, and the negative can of course go to any ground. The signal pin needs to go to any numbered GPIO pin, and make sure you choose one which isn't in danger of also being used for anything by the touchscreen. As you can see, I went for pin 13 here, which is well out of the way. Now it's time to connect everything up, including the RFID reader, and see if it works. Take your RFID fob and hold it to the reader. It recognises that as me and displays my name and photograph. I then enter my PIN, 123456, and it then generates a random one-time access code to send to my phone as a text message. As soon as I enter this code, you'll hear the click of the relay switch coming on, and after a few seconds it clicks again to turn off. Later on, when we install this into our doorway, the relay switch will be connected to the electronic door strike, so we'll unlock the door. Next up, we need to prepare our power supply to provide power both to the Raspberry Pi, which requires 5 volts, and also to the door lock, which requires 12 volts and is triggered using the relay switch. We want the whole system to be powered using just a single power lead, so we need a single power supply which can provide both 5 volts and 12 volts simultaneously. So for that, we're using a desktop computer power supply.
At this point, it seems prudent to point out that we're about to be dealing with live electrical voltages. Low voltages, mind you, and not mains current, but the power supply itself does plug into the mains, obviously. Therefore, proceed at your own risk, and only if you are confident and sure about what you're doing. If you are in any doubt whatsoever, do not continue, and instead consult an experienced, qualified, and competent professional. I can accept no liability whatsoever for your actions. Got that? Right, as we were.
As you'll know, computers don't immediately turn on when you plug them in, even with a little switch on the power supply itself in the on position. You have to press the on button on the front of the computer tower first. Well, in our case, we do want the power supply to turn on using just its own switch, so we need to do a little bit of electronic wizardry. Of the myriad cables coming out of the power supply box, you'll find just one green cable. This is the signal cable, and it needs to be permanently shorted out to a black ground cable. So take the green cable and any black cable and snip them with a pair of scissors, and then strip a short length from each end to expose the bare wires inside. Twist them together so they don't fray, and then take a chock block and cut one from the end. Connect the green and black cables together, and then test it works by plugging in the mains power and turning on the PSU. It works. Now we need to take one of these SATA power cables, which usually provides both 5 volts and 12 volts to a hard drive, and test the contacts with a multimeter to double check which is which. Place your multimeter's black contact on the black ground wire, and then test both the yellow and red contacts to check which is which. As you can see, the yellow is giving us 12 volts and the red is giving us 5 volts. Chop off the SATA connector to reveal 2 pairs of cables, a 5 volt with ground and a 12 volt with ground. Strip the ends off each wire, twist them to stop them fraying, and then chop off a 4-way section of chock blocks. Connect the 4 cables into the chock blocks like this, giving us a handy source of both 5 and 12 volts power. Next, take the power supply which came with your Raspberry Pi. Although it's a micro USB plug on the end, as it's only supplying power and there's no data transfer going on, the cable only has 2 cores, positive and negative. Snip the cable off the power supply and then separate the 2 cores for a couple of centimeters. Strip and twist the ends, and then look for the marking on the cable to determine which is the negative. If there aren't any obvious markings on your cable, you'll have to use your multimeter and do some detective work. Connect the USB power cable into the chock block we just prepared, making sure you connect it to the 5 volt supply, which is red in my case. We can now check this works by connecting the power cable to our Raspberry Pi and then turning on our power supply unit. As you can see here, it works just great. Now it's time to turn our attention to the electric door strike. This is the catch which sits in the door frame and is normally closed, so won't allow the door to open unless 12 volts is supplied to the strike, in which case it allows itself to be opened, effectively unlocking the door. If we open up the strike, you can see 2 very thin wires which were meant to be soldered to contacts on this black plastic top. On my one, the wires are so thin and flimsy that they've broken off already in transit. So to remedy this, we'll remove the black plastic clip holding the contacts and solder some longer pieces of wire on. We've got some handy, as we just chopped it off the power supply, so let's take a couple of lengths of wire from that, snip them and then strip and twist the ends. Now it's time to get your soldering iron out and tin the exposed ends of the wires with some solder before bringing over the door strike and soldering our new lengths of wire to the 2 very fragile exposed wires up top. Partly to avoid short circuits and partly to help stop it breaking, I'm going to put some electrical tape over both joints like this. Now it's time to test the door strike, so let's wire it directly into our 12 volt power supply that we created before and watch what happens when we switch on the power. The door strike now needs to be installed into your doorway in place of your existing striker plate. Here, I'm installing the system into this mock-up of a door frame that I've knocked together as a demo, so you'll have to excuse the slightly shoddy woodwork. On mine, the electronics are going to be located within the stud wall, but make sure you comply with all building regulations in your region before continuing. The first step is to drill a reasonably sized hole to allow cables to be poked through the timber to the power supply, which will sit below. Run the cables for our dual voltage supply up the vertical beam and drill a small pilot hole through the centre of the chock block and then screw in place. Then poke the USB power cable up through the hole to provide power to the Raspberry Pi. Next, we need to decide on the arrangement of our components within the stud wall, and I'm using a spare block of wood from a previous project to create a little platform onto which I can mount the GPIO expansion board. The relay will sit just here on the vertical beam next to the electronic strike. The Raspberry Pi's case has mounting points on its base, so measure the distance between them and then transfer that measurement to the horizontal beam, marking 2 points to insert some small screws nearly all the way down but not quite. With those in place, the Raspberry Pi can be placed on and slid back, holding firmly in place. The power cable reaches neatly to the socket and can now be plugged in. Secure the mounting block in place and try not to split the wood like I did here. Oops. Drill a pilot hole if necessary to avoid that. Then screw down the GPIO expansion board and secure the relay switch in place near the electronic strike. Next, wire in one of the cables directly from the door strike to the normally open terminal on the relay. Either one will do, as it's not a polarized component. Then, connect a length of cable to the ground terminal, poke it through the hole we drilled, and then connect it to the negative terminal of our dual voltage power supply. Finally, connect the door strike's other wire to the 12-volt positive supply. Next, we need to cut the holes in the wall to mount the RFID reader and the LCD touchscreen. I marked the holes out first on a serial packet to get the placement just right, before using that as a guide to mark out the holes on the wall. Drill a hole in the centre of the area to be cut away, then use a jigsaw to cut out both squares. I used some insulation tape to make the edges look a bit neater on my demo unit. You can of course make yours look much better than mine, I'm sure. To mount the RFID reader, I'm using some hot glue on the half of the front that doesn't contain the infographic, and then pressing that up against the wall. I also use some gaffer tape to help secure it in place, as this USB model isn't one which is specifically intended for wall mounting. I'm mounting my LCD touchscreen in the same way, which isn't ideal and I wouldn't recommend this method in the real world, but it should work just fine to demonstrate for this build. Next, connect up the mini USB cable to the RFID reader and boot up the Pi to test it's working. Now it's just time for the finishing touches, so let's use some blocks to hold the power supply in place and then trim down the excess length on all of our cables. Carefully disconnect them one by one, cut to the appropriate length, strip and twist the ends and then reconnect. Then use some tacks to hold them neatly in place. And we're done. To summarise our build, we have an electronic door strike which is activated by the relay switch here, which in turn is controlled by the output from our Raspberry Pi, which denies or grants access using the RFID reader and touchscreen input. It also connects to the internet via Wi-Fi to use a web service to send the one-time passcodes via SMS to the user's phone, acting as 3-factor authentication. The whole thing is powered by a computer power supply which sits down here in the wall.